Hello friends, welcome to my channel. In this video, I will show you how to implement hybrid Active Directory solutions in AWS. First, I will show you how to install and configure a new single domain forest on EC2 instance, which will simulate on-premises Active Directory. Next, I will show you how to deploy AWS managed Microsoft AD into an VPC. Then I will show you how to set up two-way forest trust between the simulated on-premises Active Directory and AWS managed Active Directory. And I will also show you how to implement federation to the AWS management console from the managed Active Directory domain. We will create users, groups, and configure mapping between these and IAM roles. At the end, we will be able to give console access to the on-premises Active Directory users based on their security group memberships over the Forest Trust. Before we dive into the demo, let me quickly introduce about myself. My name is Srinivasan. I have over 21 years of IT industry experience, and I am also an AWS community builder. And these are the AWS certifications that I have achieved in the past. And I am also an ex AWS partner AI/ML Black Belt and ex AWS partner ambassador. I think that's enough introduction about me. Now let's quickly see what AWS Directory Service is. AWS Directory Service is a managed service offering providing directories that contain information about your organization, including users, groups, computers, and other resources. As a managed offering, AWS Directory Service is designed to reduce management tasks, thereby allowing you to focus more of your time and resources on your business. There is no need to build out your own complex, highly available directory topology because each directory is deployed across multiple availability zones and monitoring automatically detects and replaces domain controllers that fail. In addition, data replication and automated daily snapshots are configured for you. There is no software to install, and AWS handles all of the patching and software updates. AWS Directory Service enables you to rapidly lift and shift AD dependent workloads to the cloud and simplifies application modernization via seamless integrations with AWS services. With AWS Directory Services, you can create a new directory, extend or connect your existing directory, and seamlessly deploy workloads into Amazon EC2, which are automatically connected to your AD or to managed services like RDS and FSX. AWS Directory Service also integrates with the AWS applications like workspaces, enabling your end users to use their existing corporate credentials directly. Additionally, you can manage users and groups, provide single sign on to applications and services, create and apply group policy, join Amazon EC2 instances to a domain, and simplify the deployment and management of cloud based Linux and Microsoft Windows workloads. You can also use your existing corporate credentials to administer AWS resources via AWS IAM role based access to the AWS Management Console. Now let's look at the directory service solutions offered in AWS. First, AWS Managed Microsoft AD. AWS Directory Service for Microsoft Active Directory, either Standard Edition or Enterprise Edition, is an actual Microsoft Active Directory in the AWS cloud. You can use it to support Active Directory aware workloads like Amazon RDS for Microsoft SQL Server, AWS managed services such as Amazon Workspaces and Amazon QuickSight, or Linux applications that require an LDAP directory. Your end users benefit from a Windows integrated single sign on experience, whether you use it as a standalone directory in the AWS cloud or you extend your existing Active Directory infrastructure into the AWS cloud using an Active Directory trust. Next, Simple AD. Simple AD is a low scale, low cost directory with basic Active Directory compatibility. You can use it as a standalone directory in the AWS cloud to support AWS applications and services, support Samba 4 compatible applications, and to support Linux applications that need an LDAP directory. Next, AD connector. AD connector is a proxy that enables you to use identities from your existing self managed Microsoft Active Directory with compatible AWS applications. You can also use AD connector to join Amazon EC2 instances to your AD domain and manage these instances using your existing group policy objects. This makes it easier to deploy AD aware applications on these Amazon EC2 instances and use your self managed AD for user and group authorization. Now let's look at AWS managed Microsoft AD in a little bit more detail. AWS Directory Service for Microsoft Active Directory, also referred to as AWS Managed Microsoft AD, runs Microsoft Active Directory as a managed service powered by Windows Server 2019, and it is highly available. It creates a highly available pair of domain controllers in your Amazon VPC across different availability zones, with AWS automatically managing host monitoring, recovery, data replication, snapshots, and software updates. And it enables you to run directory aware workloads, manage users and groups, provide single sign on, create and apply group policies, and securely connect to Amazon EC2 instances. Directory Service offers two Microsoft Active Directory solutions. First, AWS managed Microsoft AD Standard Edition and Enterprise Edition. It creates new managed AD domains to manage users, devices, and computers on AWS. These directories establish a resource forest that create trust relationship with your existing AD domains on premises, in AWS, or in multi-cloud environments. Users can access AWS resources with their existing credentials from your current AD domains. User identities stay in your existing AD domains while the resource forest manages your AWS resources, maintaining operational isolation between environments while providing seamless single sign on. Next, AWS managed Microsoft AD Hybrid Edition. It connects your self managed Active Directory with AWS Directory Service for Microsoft Active Directory, creating an integrated identity environment spanning both your infrastructure and the AWS cloud. This solution extends your directory services to AWS without synchronizing user identities, establishes trust relationship between environments, and provides seamless access using existing credentials. Now let's look at some of the use cases. First, sign into AWS applications and services with Active Directory credentials. You can enable multiple AWS applications and services such as AWS Client VPN, AWS Managed Console, AWS IAM Identity Center, Amazon Chime, Amazon Connect, Amazon FSx, QuickSuite, Amazon RDS for SQL Server, WorkDocs, Amazon Workmail, and Workspaces to use your AWS managed Microsoft AD directory. When you establish an AWS application or service in your directory, your users can access the application or service with their Active Directory credentials. For example, you can enable your users to sign into the AWS Management Console with their Active Directory credentials. Manage Amazon EC2 instances. Using familiar Active Directory administration tools, you can apply Active Directory group policy objects to centrally manage your Amazon EC2 for Windows or Linux instances by joining your instances to your AWS managed Microsoft AD domain. In addition, your users can sign in to your instances with their Active Directory credentials. This eliminates the need to use individual instance credentials or distribute private key files. This makes it easier for you to instantly grant or revoke access to users by using Active Directory user administration tools you already use. provide directory services to your Active Directory aware workloads. AWS Managed Microsoft AD is an actual Microsoft Active Directory that enables you to run traditional Active Directory aware workloads such as Remote Desktop Licensing Manager and Microsoft SharePoint and Microsoft SQL Server always on in the AWS cloud. And AWS IAM Identity Center to Office 365 and other cloud applications. You can use AWS Managed Microsoft AD to provide AWS IAM Identity Center services for cloud applications. You can use Microsoft Entra Connect, formerly known as Azure Active Directory Connect, to synchronize your users into Microsoft Entra, that is formerly known as Azure Active Directory or Azure AD, and then use Active Directory Federation so that your users can access Microsoft Access Office 365 and other SAML 2.0 cloud applications by using their Active Directory credentials. Integrating AWS Managed Microsoft AD with the IAM Identity Center adds SAML capabilities to your AWS Managed Microsoft AD and are your on premises trusted domains. Once integrated, your users can then use IAM Identity Center with services that support SAML, including the AWS Management Console and third party cloud applications such as Office 365, Concur, and Salesforce without having to configure a SAML infrastructure. Next, extend your on premises Active Directory to the AWS cloud. If you already have an Active Directory infrastructure and want to use it when migrating Active Directory aware workloads to the AWS cloud, AWS Managed Microsoft AD can help. You can use Active Directory Trust to connect AWS Managed Microsoft AD to your existing Active Directory. This means your users can access Active Directory aware and AWS applications with their on premises Active Directory credentials without needing you to synchronize users, groups, or passwords. For example, your users can sign into the AWS Management Console and Amazon Workspaces by using their existing Active Directory usernames and passwords. Share your directory to seamlessly join Amazon EC2 instances to a domain across AWS accounts. Sharing your directory across multiple AWS accounts enables you to manage AWS services such as Amazon EC2 easily without the need to operate a directory for each account and each VPC. You can use your directory from any AWS account and from any Amazon VPC within an AWS region. This capability makes it easier and most cost effective to manage directory aware workloads with a single directory across accounts and VPCs. For example, you can now manage your Windows workloads deployed in EC2 instances across multiple accounts and VPCs easily by using a single AWS managed Microsoft AD directory. Now let's see the steps to set up two-way trust. First, deploy on-prem AD. In this step, we will create a new EC2 Windows Server instance. Then we will install and configure a new single domain for us on this EC2 instance, which will simulate on-premises Active Directory. Next, deploy managed AD. In this step, we will deploy AWS managed Microsoft AD into an VPC. When you select and launch this directory type, it is created as a highly available pair of domain controllers connected to your VPC. The domain controllers run in different availability zones in a region of your choice. Next, administer Microsoft AD. In this step, we will deploy a management server in your VPC and install the necessary Active Directory tools to manage the data within your AD running on AWS. Next, set up the trust. In this step, we will set up two-way forest trust between the simulated on-premises Active Directory and AWS managed Active Directory. Integrating IAM and AD. In this step, we will implement federation to the AWS Management Console from the Managed Active Directory domain. We'll create users, groups, and configure mapping between these and IAM roles. At the end, we will be able to give console access to the on-premises Active Directory users based on their security group memberships over the Forest Trust. Now let's see the architecture that we already have. So this is the architecture that I have already created. I have created an simulated on-premises environment that is on one AWS region, and I have created another AWS VPC in a different region. So, for example, this corporate data center I have created in a one domain or one region, and this one I have created in another region. And I have already created a VPN connection, site to site VPN connection between the simulated on prem environment to the AWS cloud. If you want to know how to set up VPN connection, please refer to my channel. I already have a video in depth, I'll walk you through how to create a site to site VPN connection, or even if you want to create client VPN. I will give a link to those videos in the description. So next, let's simplify this architecture and show you how what we are going to implement in this video. So this is the simplified architecture that we have already implemented. And first, what we'll do is like we will create on-prem Microsoft Active Directory. We will do that on a Amazon EC2 instance. Um, then we will create AWS managed Microsoft AD. As if you know, as I already told you, it creates two highly available pairs of AWS managed Microsoft AD in AWS managed VPC, and we will be given with two ENIs. So when we create AWS managed AD, we need to give the region and the VPC and also the subnets that we want to create. So we need to create two subnets. So what AWS does is like they provision AWS managed Microsoft AD in a VPC, and then we will be given a ENI and two of the subnets that we select when we create the AWS managed Microsoft AD. I will show you when we go into the console, like once we create and then where the ENIs are provided. So because it is AWS managed, we cannot log into the AWS managed Microsoft AD directly to manage. So for that, we need to create an EC2 instance to manage the Microsoft AD. So we'll create an AD management server and install the required tools to manage the AWS managed Microsoft AD. So that's what we are doing it here. Once we are done, we will set up a forest trust, two-way forest trust between the simulated on-prem Microsoft AD to the AWS managed Microsoft AD. Once we set up the forest trust, on-prem users will be able to access the instances on the AWS side using their credentials, their existing corporate credentials. We don't have to have an IAM user or we don't have to create a credential in the AWS managed Microsoft AD. The corporate users can use their existing corporate credentials to log in. I will show you how we can do that. And we will also show you, I will also show you how to integrate IAM with this one, as I said. So these are the some of the applications, AWS applications and services that we can integrate. So what we will do is like we will implement federation to the AWS management console from the managed Active Directory domain. We'll create users, groups, and configure mapping between these users and groups that are being created in the on-prem environment. and we will create the federation between them and the IAM roles. At the end, we will be able to give console access to the on-premises Active Directory users based on their security group memberships for the forest trust. This is the architecture that we are going to implement in this video, and I'll walk you through the process step by step. I think that's enough theory. Let's dive into the demo. Let's log into the AWS Management Console, and I'll walk you through the process. Okay, I have now logged into AWS Management Console. Now I will show you the simulated on-prem environment and AWS environment. Um, Currently, I am on Oregon region, that is US West 2. This is the region that I am using for simulated on-prem environment. Let's go into VPC, and I'll show you the VPC that I am using for on-prem corporate environment. I have created a VPC named on-prem VPC, and you can see that its CIDR range is 192.168.0.0/16. That's the IP CIDR range for on-prem environment, and you can see the subnets. I have four subnets, two public and two private subnets, and two different availability zones: US West 2A and US West 2B. And you can see the route table. So we have one route table for the public and two private route tables. You can see the routes. If you see that routes, um, so the public route table for internet, we are using internet gateway, and so this is to reach AWS side 10.0.0.0/16. That's the IP side range that I'm using on AWS side. That will go through the on-prem router, and for 192.168.0.0, that's the local route. And if you see uh, the route table for this one, so that's the same. So we don't have this is the private route table. So if you need to access internet, it goes through the NAT gateway, and to reach AWS site, it will go through the router, and a local route. No, for local, it is 192.168.0.0/16. It's the local route. That's going to be the same for this route table. So, so internet access is provided through NAT gateway, outgoing internet access, no incoming internet access. It's the private subnet. If you see that subnet association, also you can see that like it's the private subnet. And if you want to reach AWS side, that is 10.0.0.0/16, that will go through the on-prem router, and through the VPN connection, and 192.168.0.0/16 is the local route. And if you see that internet gateway, we have an internet gateway, and that is used for public route table. And here we have that NAT gateway. And if you see the security groups, so I have created some security groups. I will walk you through that later. And this is the on-prem environment. So this is the US East 1, North Virginia region. So let's go into VPC. So I'm using US East 1 region as a AWS side. And if you see the VPC, I have created a VPC named AWS VPC. And the IP CIDR, it is 10.0.0/16. And you can see the subnets. Yeah, we have four subnets, and two public and two private, and two different availability zone: US East 1A and US East 1B. And if you see the route table, so for the public route table, So we have the two public subnets that is associated with this and the route. So for the internet bound route goes through the internet gateway, and this is the local route 10.0.0/16. And to reach on-prem side, that is 192.168.0.0/16, it will go through the virtual private gateway. So and this is a propagated route. So you can see that here from the AWS side, we can enable route propagation, and I have already enabled it. And if you go back and you select the private one route table, so it seems the private one subnet is associated with this route table, and internet bound access, outbound access goes through NAT gateway. There is no access from the internet, it's the private subnet. And this is the local route, and on-prem side will go through the virtual private gateway. That's going to be the same for next route table. You can see the subnet association here and the route, it's going to be the same. And if you see the internet gateway, yeah, we have one that is associated with this VPC. So we have two. This is for the default VPC, and this is the one for AWS VPC actually. And we can see the NAT gateway, and you can see the security groups. I'll talk about this in detail later. And let's go to VPN section. And if you see, we have a customer gateway, and that we have created. This is the reference to the actual customer gateway on-prem router that we have. And you can see that this is the IP address for on-prem router, and we created that, and we have created a virtual private gateway, and that is attached to AWS VPC. And we have site-to-site VPN connection. And if you see the tunnels, we have two tunnels and both are up and running. And if you want to know how to set up AWS site-to-site VPN or AWS client VPN, I already have a detailed video in my channel, and I'll give you a link to those videos in the description. And also please subscribe to my channel for more AWS related videos. And can see that this is the AWS side, and then this is the on-prem side, and we have the tunnels, everything up and running. So I will just log in to the instance and then show you how we can access the instances from on-prem to the AWS side. Let me minimize this one. Okay, let me go and open this one here, and let me, this is the Windows app. Let's go ahead and add PC. Okay, yeah, before I do that, let me get the IP address. So this is the Oregon region, that's for on-prem environment. Let's go to EC2. So we have two instances that are running. So if you see, this is the instance that access a router, on-prem router. This is Ubuntu server, and so I have already created another Windows server that acts as an on-prem Windows server. Let me copy the IP address here, and also let's click on connect and RDP client. Um, and this is the Windows instance, so we need to get the password, and we need to upload the private key file. This is, I already have associated this instance with on-prem KP, this key pair. Let's upload it and decrypt the password. Okay, so here is the password. Let me first go into the Windows app. Let's add a PC, give the public IP address for the on-prem Windows server. Let's give a friendly name. I'll give let's name it as on-prem Windows server and add it. Okay, once we add that, let's get the password for this instance. Got the password. Let's double click on it, and let's Let's log in as the administrator and give the password. Let me also save the password, okay, in the notepad. Let's click on continue, connect, okay. It's connecting to the on-prem Windows server. Okay, we have connected. Yeah. Let's open Windows PowerShell and run as an administrator. Let's see if we can ping instance from AWS side. Let's minimize this one. Let's go into AWS side and let's go into EC2. This is US East one, North Virginia region. Let's go into instances, and I already have a private EC2 instance that is on the private subnet. So if you see, if there doesn't have any public IPv4 address, and IP address also, it's in the 10 network. If you remember, the VPC is in 10.0.0.0/16 CIDR range. Let's copy this private IPv4 address for the on-prem, not on-prem, AWS private EC2 instance. Let's go back to the on-prem Windows server and see if I can ping this instance. Yep, it works. So this is just to show you our AWS site-to-site VPN connection that is working fine. So now let's go ahead and create new EC2 instance. Then we will install and configure a new domain for us on that EC2 instance that will simulate on-premises Active Directory. So let's go into on-prem side. This is again Oregon side. Let's go to instances. Let me click on launch instance. Let's name it on-prem DC. It's going to be the Windows instance, obviously. And let's use the latest AMI, Microsoft Windows Server 2025 base. That should be fine. And instance type, let's go ahead and create T3 medium. And I'm going to use an existing key pair. I already have on-prem key pair. I'm going to use that. Let's edit the network settings. Select on-prem VPC. That's the simulated on-prem corporate data center. And for the subnet, I think that's good. On-prem subnet private 1 instance. So that's good. Let's create it on the private subnet. And anyway, we don't have an IP address. We don't need one. And let's see if let's create a new security group. Okay, let's name it on-prem DC RDP security. Okay, or I can just do it on-prem DC security group. So I'm going to use the same for the description here. For the inbound rule, we need RDP, and for now I'm going to leave it as anywhere, but in production environment you don't want to use it. You may want to restrict it to your IP address or custom IP ranges. So for now I'm just gonna have it anywhere. Once this demo is done, anyway I'm gonna tear down and terminate the instance. So for now I'll just leave it to anywhere, and everything else looks good. Let me go ahead and launch the instance. Okay, on-prem DC instance is created and it is in running state, and the status check is passed. Now let's click on connect and click on RDP client, click on get password. upload private key file and from, let's click on that decrypt password and then let me copy it to the notepad. Okay. Now, if you remember like this, on-prem DC is created in a private subnet with a private IP address 192.168.141.91, and it doesn't have any public IP address. It is on the private subnet, obviously. So we cannot directly log in to this instance from internet, and we should we will be able to access it from the public subnet from on-prem Windows server. You see, on-prem Windows, we already have on-prem Windows server, and it is on the public subnet and it has a public IP address. So we are going to use this give security group that is assigned to this on-prem Windows server security group. We will give RDP access for this security group, so that we will be able to log into on-prem Windows server. We'll use this as a jump box, and then we will RDP into on-prem DC. Okay, let's go ahead and fix the security group real quick. Click on security groups, select on-prem DC security group, edit inbound rule. Let's add a new rule. Let's do RDP and leave it as a custom, and then select the security group that is assigned to on-prem Windows server, on-prem Windows server security group. So we need to be able to RDP from the on-prem Windows server into the on-prem DC. We don't need this one. We'll delete it. Okay. Now let's save the rules. So now this is fixed. This is good now. So let's go ahead and you know uh, connect to the on-prem DC. Let me maximize this one a bit. Okay. Here, let me go into Windows Tools. Yeah. Now let's select a remote desktop connection. Now we are currently on on-prem Windows server that we are using as a jump box. Now let's connect to on-prem DC with a IP address that is, okay. Come on. Let me copy the IP address. Okay, let's connect. And let's log into this one as administrator. And the password that we have already decrypted. Okay. Say yes. Okay, now we have logged in to on-prem DC. So you can see that like IP address 192.168.141.91. That's the IP address for on-prem DC. Once its log setup is completed, we can install AD on on-prem DC. So before we do that, let's quickly fix the DNS. So we'll open network connections, double click on it, go into properties, select IPv4 properties, and set the DNS here to the local address 127.0.0.1. So 127.0.0.1. So that's the DNS address for on-prem DC. That's good. It's done. Okay, let's close this one. And let's open Windows PowerShell. Let's right click on it and run as administrator, and let's install AD domain services. So this is the command to install AD domain services. So this is gonna take some time. I will pause the video and then come back once the installation is completed. Okay, AD domain services installation is completed. You can see that it is success, and exit code is success, and then restart is not needed. Now let's go ahead and install ADDS forest and create the domain. I'm going to name the domain name as onpremad.local. So let's go ahead and execute this one. So it's asking safe mode administrator password. We need to provide that one and then remember it. Let's confirm. Now, so it's going to start the installation for ADDS Forest. It's going to take some time. Once the installation is complete, instance will automatically restart. So I'm going to pause the video and come back once the installation is completed, and once the has restarted automatically. So okay, now ADDS Forest service is installed and the on-prem DC server and the on-prem ad.local domain is created. Now let's log back into the on-prem DC. This time let's not use the local administrator user. Instead, let's use our the domain username. Let's do on-prem ad.local, and then let's do administrator. So we are not using the local administrator account. We are using the domain account. The on-prem ad.local is the domain that we created on on-prem DC, and the password is going to be the same password that we decrypted using the private key file on-prem key pair for the regular administrator user account. The same password, but the username is it's a different account. It's the domain account. Let's log login. Okay, click on it. Say yes. Yep. So yeah, we have logged into on-prem DC using our on-prem AD domain username on-prem ad.local administrator account. That's good. So let's go ahead and minimize here, and let me show you how to create AWS managed Microsoft AD. Uh, let me um, let me minimize this one. Further, let's go to AWS management console, and I am on US East 1 region, and that's Northern Virginia region. This is where we have our AWS VPC. Let me go to search and search for directory service. Okay, let's open directory service in a new tab. uh, Close this one. Go to directory service. If you see, I have already created AWS managed Microsoft AD. So this is the one. This will take some time, so I have already created it, but I will show you, walk you through the process how we can create one on AWS. It's pretty easy. We don't have to do any of the steps that we did on-prem DC to install anything manually. Let's click on directories, click on setup directory, and select the directory type AWS managed Microsoft AD, and then I'm going to use select this one, create new AWS managed AD domain. I'm not going to use extending your existing AD domain with a hybrid directory. Maybe that I will do in a new video later. Just please let me know in the comment if you want to see how this is actually a little bit costlier implementation. So it's gonna cost you enough almost $468 per month. So I'm not going to do that now. So I'm going to use create new AWS managed AD domain. Go next, select standard edition, and so you can just show that car.sample.com and say car for the NetBIOS name. So this is optional. I'm not going to do it like for the this one. I'm just going to give a password, admin password, and whatever the password that we give here, you need to remember it. If you see this is the admin username. So the default username for AWS managed Microsoft AD is admin, and the password that we give here, you should remember that, so we can use this to log in. Go next. I'm not saving it, and let's select the VPC. So this is the AWS VPC and our US East 1 region, and it's IPv4 subnets. We need to give two subnets, so I can do private 1 and private 2. If you remember, when you select and launch managed Microsoft AD, it's created as a highly available pair of domain controllers connected to your virtual private cloud VPC. But since the domain controllers are managed by AWS, you cannot log into their domain controllers using remote desktop connection or anything. In order to manage the data within the AWS managed AD, like users, computers, group policy, sites, site links, DNS, etc., we need to deploy a management server in your VPC and install the necessary Active Directory tools to manage the data within your AD running on AWS. Okay, and we need to, we want to join the new management instance to our existing managed Active Directory. So you can use AWS Systems Manager to automatically join an instance to the domain. In order to do that, you need to configure an AWS IAM instance profile role for Systems Manager and then attach it to the EC2 instances, that is the management server. So I will walk you through the process how we can do that. So let's quickly complete this one here. So if you go next, so that's all it is needed here. So if you review, and then if everything looks okay, you can go ahead and create the directory. But I'm not going to do that because we already have the directory created. I'm going to leave this one. So this is the directory that we already created. The directory DNS name is awsad.local, and the NetBIOS is awsad. And so so if you see the networking and security here, it has two DNS IPv4 address. Just make a note of it. We'll need it later. And then if you see that, it's availability zones, East 1A and 1B that I have used. So this looks okay. So let's go back to the EC2 instances and Northern Virginia region here, and let's go ahead and launch instance. Even before we do that, let's go ahead and create the IAM profile. Let me search for IAM. Yep, let me create open the link in the new tab. Go here and let's go into roles, and let's create a role. And AWS service is EC2, and go next. Okay, now let's search for Amazon EC2 role for SSM. Let's do EC2. Okay, yeah, we want this role, Amazon EC2 role for SSM. Select that one and go next and give the name. So this is EC2 domain join role. Okay, okay, just the typo. Okay, it's easy to domain join role. Just named it, and everything looks good. And if you see, this is the trusted entities. So the EC2 instance is going to trust that, and the permission policy is Amazon EC2 role for SSM. Let's create the role. So it's created. Now let's go back to EC2 instances and let's launch a new instance. So let's name it as AWS management server. Okay, let's name it as AWS AD management server. Okay, I can do that. AWS AD management server. Select Windows and latest AMI. For the instance type, let me go ahead and create T3 medium and key pair. I'm gonna select AWS key pair for this region. And network settings, let's edit here and select our AWS VPC. And for the subnet, let's create it on the public subnet. And let's select the IP address, auto assign the public IP address, enable it, and let's create a new security group. Let's name this as AWS AD management server security group. I'm going to use the same for the description here. And for the inbound rule, so we need to be able to RDP protocol, RDP protocol, and source I'm going to leave it as anywhere. So you may want to restrict it in the production environment. So for now I'm going to leave it, and then I will anyway terminate the instance after the demo is completed. This looks okay, and let's go into advanced details. And we need to select the domain that we need to join. So I already have this domain awsad.local. This is the managed AD on AWS. Let's select that one. So when the instance is created, it will automatically join to this domain seamlessly. So and then let's select the IAM instance profile. Let's search. Okay. So we created this new role, EC2 domain join role. Okay, select this one. So this one will help us to join AWS systems manager will help us to join the AWS AD domain. Then everything else looks good. I'm not going to change anything, touch anything here. Let me go ahead and launch the instance. So it's going to take some time. Once the instance is launched, and it will be joined to the domain. Once this instance is in available state, we will be able to log into this instance using a remote desktop protocol connection. But we can use directly that admin username for the AWS AD domain. We don't have. Okay, now the AWS AD management server is launched and it is running, and the status check is passed. So let's click on this one and check. Let's log into this one using remote desktop connection. Let's copy the public IP address. We don't have to decrypt the key pair to get the password, because this AWS AD management server has joined to the AWS AD.local domain that we created for manager AD. So let's log into this one. So first, let me go to Windows. Yeah, so I don't need this one. I'm just gonna minimize this one, and yeah, let's minimize this. I don't need it now. Yep, let's go ahead and add new PC on the Windows app, and let me give you the public IP address for the AWS AD management server, and I'll name it as AWS AD AWS AD management server. Let's add this here, and let's double click on it, and let's use the domain username awsad dot local slash admin. If you remember, the default username is admin when we created the managed AD, and you need to remember the password that you provided when you created the managed AD. Okay, let's continue. So it's so we are able to log into this AWS AD management server successfully using our domain username on awsad.local/admin and the password that we created when we created the managed AD. So once we log into this management server, let's install that remote server administrative tools. So let me, yeah, let's come in here. It's almost done. It's logged in. Let's click on Windows PowerShell and right click on it and run as administrator. Yes, and I'm gonna install using this command. I'm gonna install the Windows feature that includes also feature of remote server administrative tools. So this is gonna take some time. So I'm gonna pause the video and come back once the tool is installed. Okay. Remote server administrative tools features are installed, and if you see that it's success, exit code is success, but restart is needed. So I'm gonna restart this, AWS AD management server and come back. So let's start here and then restart. Okay, it's going on. So I'll pause the video and come back once this instant is restarted. Okay, the restart is completed for AWS AD management server. Let's log back in. Click on it and let me log in as the AWS AD domain user. Continue. So click on the Windows icon. Click on all here. If you go and see Windows tools, so all the administrative tools are installed. You can see Active Directory, users and computers, domains and trust. So all the tools are installed. I can just click on it here. You can see that AWS AD domain here, and if you see the DNS, NetBIOS, so you can see the users here. We have, if you remember, we logged into this instance using admin user. So the default username for AWS managed AD is admin, and we can see the delegated groups stuff. This looks fine. So let me go and minimize this one and also install that remote server administrative tools on on-prem DC instance also. So let's minimize this one, and I have the instance already connected. Let me open that up here. Yep. Let's go into the DC. Let's maximize this one. Okay. So now I'm on on-prem DC server. You can see the IP address 192.168.141.91. That's the on-prem DC server IP address, private IP address. Let's right click on the Windows PowerShell and let's run it as an administrator. And let me install Windows feature RSAT. So it's gonna take some time. Once it is done, we need to restart this instance also. So okay, RSAT Windows feature is installed on-prem DC. So you can see that, like, it's installed on success and its restart is needed. So let me go ahead and restart this on-prem DC. Okay. So when this is getting restarted, let's go into the AWS management console and make sure that we allow the necessary communications between the directories. Let's okay, let me minimize this one a little. Okay, so now we are on Oregon region, that is on-prem region. Let's go into the security group here and select on-prem DC security group. If you remember, we only allow that inbound rule that is from the security group that is associated with the on-prem Windows Server security group. So this one is 60A. If you see that, this is the 60A. This is on-prem Windows Server security group. So we allow RDP from this security group. And if you see the outbound rules, by default, it's all traffic is enabled to the wide internet. So I'm not going to restrict it for now. So let's go back to inbound rules and let's edit the inbound rule and add a rule. So we need to enable, DNS service on port 53 and Kerberos authentication on port 88 and LDAP on 389 and SMB on TCP 445. So for this demo, for simplicity purpose, what I'm gonna do is I'm gonna select all the traffic, leave it as custom, and all the traffic that comes from AWS side, that is AWS cider range. Let me give 10.0.0/16. So I'm allowing all traffic from the on-prem VPC cider range. So we don't want to do this one in the production environment. So just for this demo, I'm just for simplicity purpose, I'm just enabling setting this one here. Okay, once okay, this is done. Now let's go back to let's go back to the AWS side. Let's minimize this one here, minimize this one here. This is fine. And let me go ahead and let's open. Okay, let me go ahead and I think I closed that window. So let me go ahead and on a new tab. No, I don't want. I just want a new window. Okay, let me go into US East 1, North Virginia region, and go into VPC and select the security group. And so if you see, like, we have this security group that is automatically created when we created that AWS managed AD under the directory services. So this is if you open a directory service, let me open this in the new tab. Okay, here if you go the directory ID, you can just remember that last four digit, like 8482. So okay, yeah, this tab, yeah, this is 8482 controllers. So this is the security group. Select this one, and if you see the inbound rules, let me yeah, it's allowing all these ports. It's automatically created by AWS, and we created that managed AD. And if you see the outbound rules, for now it's not restricted. It's sending all the traffic to wide internet. I'm just going to leave that as it is and click on the inbound rule and edit the inbound rule and add a rule. Add, let's say, all traffic and set it as a custom. And let's do the cider range for our on-prem DC. It's 192.168.0.0/16. Okay, so 192.168.0.0/16 looks good. Let's save the rules. This is fine. So we have now allowed the necessary communication between the directories, and now we need to configure the conditional forwarder on on-prem domain controller. I think by now it should have been restarted. Let's click on this. Okay, and now let's connect to on-prem Windows Server. Okay, yeah, here it is. Okay, let's go in here, and from on-prem Windows Server, let's RDP into our on-prem DC. This is 192.160.141.91, and log in as on-prem AD.local administrator, the domain username. Um, let's click on that. Okay, let's give this password. I have it copied it somewhere here. Okay, I think that's good. Let's go forward and connect. Yep, it's going through. Good. And now we have logged into on-prem DC, and let's configure the conditional forwarder. Let's click on Windows and click on the server manager, and let's close this one here. Let's go to tools, and let's click on DNS, and click on conditional forwarders. Click on new conditional forwarder. Okay, the domain name is like, this is we need to give a on AWS managed AD. It's AWS AD dot local, and we need to give the DNS IP address for AWS AD domain. Let's go back to the console here. Let's go into the directory service, and if you see, we have the directory, and then click on networking and security, and we have two DNS IP address. Let's copy one at a time, and then let's add it. Click, add this one. Let's get the next one. Okay, so don't worry about what if it says like unable to resolve or whatever this error. uh, for now, we have done this one. Let's store this conditional forward in active directory. Select this one and select all DNS servers in this domain. Select this one, say okay. So now we are done with that one. So let's close this one, and if you open Windows PowerShell one more time, and let's see if we are able to resolve that AWS AD domain. Let's see, NS, look up AWS AD dot local. So it's working. It's AWS AD dot local, and then the address. If you remember, these are the two DNS IP address for AWS AD dot local domain from our directory service that we just added in the conditional forwarder. So it looks fine. It's results. We are good. And even if you wanna ping, let's see, should work. Yep, it works. So We have allowed necessary communication between the directories, and we have added the conditional forwarder. Now let's go ahead and configure the trust. Click on Windows and go to Windows Tools. Now let's open the directory domains and trust, active directory domains and trust. Yeah, that's good. Let's click on on-prem.ad.local. Click on the properties. Click on the trust. New trust. Next, and let's give the AWS AD domain name. It's awsad.local. Next, it works, and then select forest trust. So we can select two-way or one-way incoming only or one-way outgoing only. So for this demo, I'm gonna select two-way trust, and we are gonna know we can do it like only for this domain or for both the domains at the same time. So for configuring the trust on the AWS side, we will do it on the AWS management console. It's a simple process, but on-prem we need to do this manually. So just let's do this. Select leave it at this domain only. Click on next and leave it at forest wide authentication, and give a password and then remember that. Okay, go next. Thing looks okay. Go next. Go next. And then do you want to confirm the outgoing trust? No. Select leave it at no, do not confirm. Or this one. And here also for the incoming trust, just leave it at no, do not confirm the incoming trust. Leave at it. Go next and click on finish. And we're good. Click on OK. So we have configured the trust on on-prem DC. So let's go ahead and complete this setup on AWS side. Let me minimize this one here, and let's go into directory service on AWS side on North Virginia region under networking and security. So for trust relationship, let's add a trust relationship, and let it's forest trust, an existing or new remote domain. So this is on-prem. So this is on-prem ad.local, and the trust password. Remember like what we gave when we installed that AWS Forest, and we gave the trust password when we created the on-prem ad.local domain. So let's provide that password here, and I'm gonna select again two-way trust direction. And for conditional forwarder, I need to give the IP address of the on-prem DC. So let's quickly minimize this. Go into on-prem DC side and go into instances and on-prem DC. So this is the private IP address for the on-prem DC. So you might remember it's 192.168.141.91. Let's copy that one here. Okay, give the IP address, and everything looks good. If you have more than one domain controller, you can add another IP address here. So we just configured a single domain controller, so I'm just giving only one. Everything looks good. Let me add, not now. So this is gonna take some time. So now it's like it's in creating state. It will take some time. So once it is created and it's in available state, I'll come back. I'm going. Okay, the trust relationship is created. Here you can see that like this is status is verified. So we have completed the two-way forest trust between on-prem AD and AWS managed AD. If you remember, like we had to do all the steps manually on on-prem domain controller to create the two-way forest trust, with the AWS AD domain. But here in the AWS managed AD's side, like it's very easy. Like we can just do everything in the console. We have created that trust relationship with the on-prem AD that local domain. Now let's go ahead and give access to our corporate users credentials to access the instance on the AWS side. So if you remember, AWS AD management server is joined to that AWS AD.local domain, and we have logged into that using admin user. Let's go to the Windows app. Yeah, we have now connected to AWS AD management server. Currently, we have logged in using admin user that is on AWS AD.local from the domain. Let's go to the here. Let's go to Windows Tools, and let's open Active Directory users and computers. Let's maximize a little so it will be better. And if you see, we have our AWS AD and the users, it's admin. And if you see AWS delegated groups, we have it here. And then if you see we have AWS delegated administrators, click on it, click on the members. Let's add. Currently, this is pointing to AWS AD.local domain. Let's change the location. Since we have created the two-way forest trust, we can see our on-prem AD.local domain also. Change this to here, and let's select admin, and then let's check the name. Yeah, we have a user named administrator in on-prem AD domain. So let's add that administrator user here under AWS delegated administrators group. So now this is fine. Let's go and close everything, and let's sign out from the AWS AD management server from this admin user that is currently logged in with AWS AD.local admin domain. Let me sign out here, and once it is signed out, let me log back in using the credentials from our on-prem administrator account. Click on this one. Let me go ahead and so we are now logging in using that with the corporate credentials on-prem AD.local administrator to this AWS AD management server, which is on the AWS side. Let me quickly get the password for this one. Okay. Yep. Let's continue. It has opened in the another window. I will just bring it back. Okay. So now we have logged into AWS AD management server with our corporate credentials, that is administrator account on from ad.local domain. So we have logged in. So we have set up the trust between on-prem AD and AWS managed AD, and then we have given our corporate credentials access to manage that instances, EC2 instances that are on the AWS side. We didn't have to create a new username here in on-prem AWS AD. We are just using the existing username and credential from on-prem AD. So now let's go ahead and integrate IAM and AD now, so we can implement federation to the AWS management console from the managed Active Directory domain. So we will create users and groups on on-prem side, and then configure the mapping between those users and groups to the IAM roles in the AWS side. So I will show you how we can do that. So now I think we don't need this AWS management ID management server for now. Let me minimize this one and let me open on-prem Windows server. Okay, fine. Let me go ahead and open a Windows PowerShell. Let's run it as an administrator. And let's go ahead and create users and groups. So let me go ahead and create an you know um, AWS developers group, and let me also create a new group, another group named AWS admins. Okay, that's done. And now let me create new user. Okay, so I'm just creating a new user named William. Okay, I'll create another user named Alex. Okay, we have created the users. Now let me add our okay AWS user one user to the this group. So I think we can use add Williams here. Let me add. Okay, and now let me add Alex to the AWS admins group. Okay. Oh, sorry. All right. Okay. I just mistyped it. Okay. Okay, I have added Alex to AWS admins group. So we are done here at the on-prem DC side. Let me minimize this one and let's open that AWS console. Again, we are now in US East 1 region. Let me open IAM and we need to create a new role. Open it a new tab and click on roles. I'll create a new role. And the service that's going to use this one is the directory service. Next, and let me give easy to read only access, Amazon easy to read only access policy. Go next. Okay, let me just name this one as easy to developer. Okay, named it as easy to developer, and it has this domain services is that trust entity, and we have the permission policy as Amazon easy to read only access. I'm going to create this one. Easy to developer role is created. Let me create another role and let me give that okay directory service. Go next, and this time let me give easy to okay sorry easy to full access. Amazon easy to full access policy. Go next. Let me name this one as easy to admin. So we have named this role as easy to admin, and the trust entity is domains directory service, and permission policies Amazon easy to full access. So this is for our easy to admin role. Let's go ahead and create this role. So we have created both the roles. Now let's go back to directory services and go into application management. So I have already created the application access URL, and if you have not created one, like you'll be given option to create one. It should be unique. So this AWS apps.com is the standard one, and we need to provide what. So I have named it as AWS AD local 1234 dot AWS apps.com. This is fine, and so we need to enable the management console. So here it is, status is enabled. I have already enabled it. You can see that, like here, AWS management console, it's enabled, and this is the URL that we can use. If you have not done enabled it, you have to come here and enable it. So I have not enabled any other services. I just enabled the AWS management console alone. So we are done with that, and let's see, like see, we our role that we have created is populated here, EC2 admin and EC2 developer, and I have created this role for a test purpose, so we can ignore it for now. So let me click on EC2 admin. Let me just, I have it earlier. I will show you how we can just do it from the beginning. I'll just go and click on add, and let me select on-prem ad.local, and then find group. And if you see, so now you can see that for our EC2 admin role, let me select AWS admins and add it. Yep, it's here, it's done. And let's go back and do the same for EC2 developer. I'll show you again from the beginning. I'll just get rid of this one. I'm gonna add it new. Select on-prem ad.local, and then find, you can use by user or group. So let's find it by group. If you see, okay, AWS. So for EC2 developer role, let's add that AWS developers group here. Done. We are done here. So let's go back here to the directory services under application management. Let's copy the URL for our management console. This is our unique URL. Let me open the new private window. Okay, it's open in another terminal, so I'll open it here. Okay, this is our URL. This is working perfectly fine. And now let's log in as our one of the users that we created on-prem. So that's William, and I'll just provide the password that I used for this user. Okay, I'm not going to save the password here. If you remember, we have added William to that AWS no developers group. So now let's click on EC2. We don't want any of this here. Let me click on EC2. We have given EC2 read-only access. So we can see the instances that are running. We can see, we can read. This is fine. But if you are trying to launch instance, it should fail. Let's click on this one. I'll just get rid of this. Let me be done. Okay. So I'm gonna name it as a test instance, and it can be anything, Amazon Linux, and uh, okay, and it can be anything. Yeah, this is fine, and I'm gonna use AWS Keeper, and I'm gonna launch it in the AWS VPC. Doesn't matter where we are launching it here, private or public, anyway, because it's not gonna launch. Um, So I will, maybe I'll just create a new security group and just leave it at SSH. This one. If I click on launch instance, it should fail. Yep, as we expected, instance launch failed because the user William is added to AWS developers group, and that group has the EC2 read only access permission policy attached to that in the IAM role. So that's it. So let's sign out from EC2 developer. William, let's sign out from here. I'll just maybe close it. I'll open another uh, private window, bring it over here. Now let's log in as our AWS admin user. That is Alex. Alex is added to AWS admins group. So that group has EC2 full access. Let me click on it. No, not this one. My bad. I need to get the. Let me copy this URL. Okay, bring it back here. Okay, come on. Okay, yeah, now you can see the URL. Let's now log in as Alex. Remember, Alex is that admin user, has full EC2 access. Let's sign. I'm not saving this. Okay, let's get rid of this one. Okay, let me go into EC2 and click on instances. So we have full EC2 permission. So we can view the instances and we can even launch the instances. This time it should not give any error. Okay. Okay. This is only, let me now like test instance. Okay. I'm just going to name it. I'm going to leave it as Amazon Linux, and T3 micro is fine. Keeper, I'm gonna leave AWS keeper. And networking, I'm gonna select AWS VPC, and any subnet is fine. I'm just gonna create a default as security group, and everything looks okay. I'm just gonna launch the instance now. So this time we didn't get any error. So the instance was no successfully launched. You can go and check the instance. The test instance is created. So we have created this instance using the username Alex, on-prem user Alex, who's assigned to the AWS admins group. So we have completed the integration between IAM and AD. So in this video, we have completed successfully, deployed on-prem AD, and then we have deployed AWS managed AD, and then we have administered both the AD, and we have set up a trust between on-prem AD and AWS managed AD, and then we were able to log into EC2 instance that is on the AWS side, that is logged into AWS managed AD domain using our corporate credentials, and we have also integrated IAM and AD. If you remember, we have implemented this particular architecture. Yep, this is the architecture that we have implemented in this demo. So this is the corporate data center and the AWS side, and we have, with the after setting up the two-way forest trust, on-prem users were able to access private EC2 instance, and then the on-prem users are given access to AWS management console, and then based on the group or the permission policy assigned, they had different permissions. So I think you have got something out of this video.